Hello, welcome to my YouTube channel. I've decided to start with density as my chapter 1, and in today's lesson, we're going to talk about definition and calculation of density. And in our lesson outline of today, we're going to look at some problem questions, illustrate some concepts of density, state the formula and the unit of density, solve some examples, and of course, there'll be some exercises for you to do. Most great discoveries in science started as observations. And after observations, scientists question their observations. Scientists are actually people who walk around the world with questioning eyes, asking questions on how and why things happen around us the way they do. Have you ever dropped a plastic bottle or a piece of wood in water? What did you observe? Did you bother to question your observation? When you drop a coin in water, what happens? Why does hot air balloon rise? Why are most balloons filled with helium gas rather than air, which is more common? What happens when oil and water are mixed together? Ship is a very huge object, but yet floats on water. Can you explain why? Sailors are advised to wear life jacket before getting into the sea. Do you know why this is required? And how does a life jacket work? This and many more are some questions and observations that are directly related to the concept of density. Illustration of the concept of density. Let us consider two common substances, sand and water, in two separate plastic cups occupying the same volume. If you weigh each of them just by lifting with the hand, you will observe that the cup of sand is heavier than that of water. If you mix the sand and the water together in a single container, you will observe that the sand will sink into the water. This further confirms that the sand is heavier than water. And if you have a balance and you can use it to determine the mass of the sand and the mass of the water, you will observe that the mass of the sand is greater than the mass of the water. So we can therefore conclude that if you have sand and water of the same volume, the mass of sand will always be greater than the mass of water. That is, sand weighs more than water of the same volume. And we can say that sand is denser than water. Definition, formula, and unit of density. Density is defined as the mass per unit volume of a substance. The density of a substance simply tells us the amount of mass packed within a given volume. And in physics or science in general, the symbol that is used to denote density is one of the Greek alphabet known as the rho. From the definition of density, the density of a substance can be calculated by taking the ratio of the mass of the substance to the volume of the substance. That is, density is equal to mass divided by volume. And from this equation, we can actually obtain the SI unit of density, which is also equals to the unit of mass divided by the unit of volume. And that gives us the SI unit of density as kilograms per meters cube. However, in most laboratory works, scientists deal with samples. And when you are dealing with samples, it is not practical to express the mass of a small sample in kilograms. Kilogram is a large unit. So scientists usually express the mass of samples in grams and the volume in centimeters cube. But grams per centimeters cube is related to kilograms per meters cube. We observe that 1 kilogram is 1,000 gram and 1 meter is 100 centimeters. So if we do some little calculation as shown, we'll end up with 1 gram per centimeters cube equals to 1,000 kilograms per meters cube, which gives us the relationship between the two units. So in the use of the formula rho equals to mass divided by density, we have three main quantities there. We have the density of the substance, the mass of the substance, and the volume of the substance. And you can calculate any of the quantities if you are given information about two. If you are given mass and volume, then of course you can just use it directly to get the density. But what if you are given density and volume to calculate mass? Then you have to adjust the formula a little bit by transposing the formula to make mass the subject, which is actually something that is done in mathematics. But if you have not yet done that in mathematics, you can simply use that triangle with the quantities inside. And the simple rule is that if you want to calculate any of the quantities, simply close it. You will see the formula to calculate the quantity. For example, if I close density, I'm going to see the formula to calculate density, which is mass divided by volume. If I close mass, I'll see the formula to calculate mass, which is density times volume. And if I close volume, I'll see the formula to calculate it, which is mass divided by density. So we have come to the end of our lesson of today. Our next lesson, we're going to be talking about floating and sinking and relative density. Another name for relative density is specific gravity. This lesson will be uploaded on Tuesday at 4 a.m. EST, Eastern Standard Time. I know this video has been helpful to you, and you can support me by liking the video. You can share, and don't forget to subscribe. Click on the notification bell to be notified when the next video drops. Thank you. This is Physics with Omia.